part B of this thing, which is the exploitation techniques, techniques in French. That's actually not how you say that in French. But so software tends to be like somebody is specializing in that like particular flavor of pen testing. I don't know a lot of people who are like equally skilled at being able to understand how to break network, a big deal. 2017 was a banner year for Microsoft, particularly CVEs. The actual NIST entry for that. For our friends at Microsoft. Anytime you see allows attackers to execute arbitrary code, that's a bad one. And again, here's our base score of 8.1 that we looked at earlier. And the various vectors that I didn't bother to drag you through, but the attack vector, the attack complexity, the privileges required. I think there's a slide back there that talks about those. The scope, blah, blah, blah. So all of the things that are in there, and then the hyperlinks to the various like web resources talking about it. This was Double Pulsar, Eternal Blue, that series of vulnerabilities. So it's kind of a big deal. And those things are, you know, the exploit DB we were looking at, Rapid7's got a bunch of stuff. There's a VulnDB that keeps track of those things. These would be great to research for our next discussion topics, by the way. Links to and finding fun stuff from Citrix Security Focus, CX Security and Security Focus. All have great examples out there. New exploits are kind of like non-trivial to create. Even when handed a binary that I knew had buffer overflows and like I had guidance on where to find them, it's still a hassle to go in and use GDB to decompile that sucker and figure out, okay, if I put in 132 A's, I'll overflow the buffer to here, and then the jump instruction should be put there, and it'll jump back to that memory. So it is non-trivial. If you can find proof of concept as a starting point, though, it does make that a lot easier. So this is why I said, like, aim for, until you're like an expert software developer, aim for developing the like HD Moore's law level of attacking a system, because you have to be not a bad programmer, and I am not as good a programmer as maybe I should be. I spend a lot of time teaching like introductory classes to programming, so like I code like a 12th grade school teacher. But you need to understand that side of things, you know, how to develop software and the cybersecurity piece to get to a place where you can do both. So you don't need to be able to like drill down to pass the Pen Test Plus. But if it's the kind of thing that gets you up in the morning, like it is a very lucrative specialization to start looking into. So if you like writing code and you like developing code and you can use a debugger, like Sophia was talking about, she went to a conference where they walked her through. What did they walk you through? You wrote a bug for something, or an exploit for something.
Reverse engineering?
Yeah.
They, even before you like wrote a bug, they did this where you didn't have code, so they like showed you how to like link the binary. After that, they started with reverse engineering, like, so this is our code, it's an if-then statement, this is how you can break that, this is how you can break the Boolean statement. They walked us through the coding logic.
But not the, like, so they showed you a working exploit, or did you reverse engineer like malware?
We reverse engineered like actual malware on their VMware, and which was the first step in the login. You had to figure out how that was going through the system. So you tagged it as login, and then you noticed it was an if-then. So if username plus password was this, then you are on level 2, else you're not lead enough. That was the phrase they used every time.
Was it 1337, or was it?
It was It was L33T.
Okay.
Same
thing.
Same, yeah. So you did teach you a little bit of coding, but it wasn't like low.
And cool that there are experiences out like that. And I totally try to get people to get involved in the community. We'll talk about this after the fact, but if you're looking for an internship, I got a friend. So compiling exploits is like after you have found the code, after you've reverse engineered the binary, after you've figured out where the thing is. If you are taking somebody else's code to try, probably a good idea to sit down and read it. And then these virtual machines we've been playing with so much, they're ideal for detonating that malware, right? You compile it, run it, make sure it works on the system that you're talking about. So compile for usually you can like C code Notepad++. I'm coming around to, I hate to admit it, I'm coming around to VS Code. It saved my bacon in a class I had last year, and it runs on Linux really nice. It's got a lot going for it, but having a IDE to work with is super fun. If you've got web extensions, use the appropriate web extension for the system. If you've got some script that's not JavaScript or HTML, make sure you've got the right scripting environment plus the right, if you're not using Bash, although sometimes it gets really close if you're in like CSH or ZSH or something. But your PowerShell scripts need to run in PowerShell, and they need to run in the right version of PowerShell, and you need to have that stupid allow unknown sources stuff turned off for it to work in PowerShell. If you're working on Perl code, I did that when I was a kid, and I don't recommend it, but it's a thing you can do. It's a write-only language. If you're doing Python or Perl or whatever, you'll need to have that Perl environment installed or the Python environment installed for it to work. If it's in a compiled language like a C or a Java sort of kind of compiles, you'll need to compile it. And so you'll not only need to make sure you've got the appropriate compiler, but that the compiler is appropriate to your target. Your target. So if you compile, usually you can cross-compile it across operating systems, right? So you could do it in Visual Studio Code on your Linux box and compile it for a BSD target or whatever. And then make sure they run on the hardware and operating system. So that's what I was getting at there, specific to, your Linux machine can make binaries for other systems, but you have to tell your compiler to do that. And then they need to be, if they're not like an executable themselves, they need to be in something that you can send over to that bad guy, or that target. Depends on, one man's bad guy is another man's good guy. But if you've taken a programming class and you've compiled a thing, do that. So, like if you Masters of Pwn competitions in that place, Zerodium, the guys who pay out for exploits, they will buy whole exploit chains from people, pay big bounty, sell your vulnerabilities to hostile foreign governments too, so like take that with a grain of salt. But they will pay for, those are desktops. How about for Android? So for Android, they want full chain with persistence. So a full exploit chain that that starts with somebody doesn't do anything. You send them to a website or something, and from there you've got access to the system with persistence. And usually that means following a chain like this, where you've got, some exploit somewhere. In this case, source code contains dev server address. Now we know where the development server is, and we chain that to error message that tell us what the software version is on that server. If we're really lucky, we find a 1990 style directory traversal bug where we just have to do ... forward, and we're all of a sudden in a different directory. Inside, we use those to log into the production server, and voila, we've breached customer data. That's one thing leads to the next exploit chain. On an application, you might start chaining actual vulnerabilities and exploits for those vulnerabilities, one into the next, to the next, to the next, to the next. So we found a vulnerability in the Java interpreter, or the JavaScript interpreter on this browser, and from that we escaped the browser sandbox and got into the browser itself, and then we found a vulnerability in the browser that allowed us to escape into the operating system. From the operating system we found a vulnerability that allowed us to escape out of the hypervisor controlling the operating system, from there control the hardware of the hypervisor. So like those kind of exploit chains are hugely complicated and like beyond the scope of this course, and usually require multiple people. Did you guys hear about this whole SolarWinds attack thing?
I've heard that, yeah.
A little bit. When Microsoft was doing the code review, just so you don't think that like I have to be able to do this all by myself, they're figuring that it was like more than 1,000 developers worked on that exploitation slash assault. Never mind how many people had to operate it after it worked. So I mean, like, these kind of huge things are sometimes, you know, back in the olden days, somebody would find a bug in DNS and it would be the, you know, bring about the end of the internet. But oftentimes more expensive, that they're willing to pay more for an Android bug than an iOS bug right now. Because to my mind that says, hey, guess what? We're good for iOS bugs. If you find one, yeah, we'll take it. But what we're really looking for right now is Android. Next time one of your friends tells you how great their iOS phone is, remind them of that little fact. So there's a bunch of tools out there to make this sort of thing easier. We don't expect every penetration testing firm to have 1,000 people at their disposal to come up with the next SolarWinds. So you tend to lean on things like exploit frameworks. We have talked about Beef a little bit for exploiting things in the browser, Metasploit for exploiting things on the network and everywhere else. Dave Kennedy, Hackin' Dave, makes a social engineering toolkit that helps make those things easier. That'll do stuff like clone web pages for you or help you with creating phishing and scamming. Proxies like Burp, just getting remote access. Did you guys hear about that water filtration plant that somebody decided they were going to turn the, what was it, the lie up to 1,000 on? It turns out that was just a remote access problem. They had, what is it, a TeamViewer installed on the machine that let you pump lie into the water supply. That's not a problem. I have two-factor on my TeamViewer that I use so that I can check my mom's computer out. You'd hope they could do that when it comes to the machine that has the lie in it, but I guess not.
I have not heard of that, but that sounds pretty bad.
Yeah, yeah. Water system. Florida. Of course it was Florida. Florida man fails to secure server should have been the headline for that article, but yeah, the Florida water system hack. Pretty scary. The deal is basically that it was a the water supply, you know, had TeamViewer running on it. So remote access is great for systems administrators. Even better for blue teamers who are defending networks so they don't have to like go into work. Super good for red teamers who are breaking into things too. Burp Suite is an intersection proxy, sits between client and server. So if you're pen testing your web app, you know, you get yourself a copy of Burp Suite. You see what kind of data flies back and forth, what kind of requests look like, all that kind of stuff. Used to be you had to install a separate proxy and set up your browser for it. Last time I played with Burp, it actually had it in like its own browser built in, so you didn't have to goof around with all that proxy stuff. We looked at network scanners like Nmap. Credential testers do exactly what they sound like, right? They go through and try out all the credentials. Now, if you really want to spend some time doing some developing, they're out there as well. But usually, ain't nobody got time for that. So you will probably use something like Metasploit to come up with those. We mentioned Beef. PowerSploit and Empire are the Windows versions of that. The Set is the social engineering toolkit I was talking about Hackin' Dave makes. So there's a bunch of them out there worth exploring. Metasploit's probably the biggest. It comes with a bunch of tools that live inside of libraries, a bunch of plugins that can be added in, and then it creates these modules that you use in order to exploit systems. And you can do that from the command line, you can do that from Armitage, which is the GUI. You can do multiplayer hacking with Metasploit, so you can have one system hosting the Metasploit, and then you can have multiple clients connect to it so everybody can see what's going on. The various components, Metasploitable, I believe you've got a copy. It's kind of a test bed to figure out how things work. You got Armitage, which is not hugely, I don't think it's in Kali 2020 anymore, but it's the front-end GUI for Metasploit. It kind of makes hacking just like almost too easy. I do this this demo of the Eternal Blue thing in one of my classes, and if we get a little more time, ask me to do it for you guys. But like I did it with Armitage once, and it's almost like ridiculously trivial. The MSF console, the Metasploit Framework console, is like the command line interface that you'll interact with. This thing here. Notice it says MSF in the corner there. Venom is the tool you use to develop exploits, and the Meterpreter is the, like, if you're going to get remote access on a system, Meterpreter is the tool that will give you all of the stuff that's like you can do on a computer. So you want to take pictures with the camera, you want to log keystrokes, you want to go through the file system, a Meterpreter session will do all those things for you. So there's a database that contains those things. It will also keep track of what you're doing. So the target list you're creating, what you found out about them, the loot you've acquired from them. It will go through and timestamp it. So if you're gonna do your documentation, you probably should be doing your notes real time. When you go back and do your documentation, you can use the SQL database that Metasploit's keeping track of to get real timestamps. And then other tools talk to that database to make it work. Too easy. You know, first you go through, you do an Nmap scan, you find some hosts, then you go through and enumerate them, then you click on the attack the thing button, and off you go. So it's almost unfair how easy it makes that. Once you've gotten into a system, you probably want some passwords. So if you find the Etsy password and Etsy shadow files on a Linux box, or the equivalent databases that are inside of Windows servers, or if you're really lucky, if you can find the ones that are inside of the domain controller, which is the sort of super system that runs the whole network in a Windows system. A bunch of Windows computers together live inside of a domain. Super useful. You can start these things. You know, you can try cracking that by brute force, which tends to be a bad way to do it. You know, starting with A and ending at Z, and then starting over with AA and ending at AZ, and then doing BA through Z and on, will work eventually. But that's a long time to wait. So better to come up with a dictionary attack that you can go through to do that, or some combination thereof, some hybrid between the two. I recommend, and I've probably recommended this to you in the past, The Secret Lives of Passwords is this New York Times article written right after 9/11 that talked about how the people who had to recover the access that the like fancy hedge funds that were in those towers had to do, and they had to do some really ingenious dictionary attacks to get that done, and interviewed, you know, family members to find out what the dog's name were. Super interesting story. I'll put that link in there too, worth checking out. If you can find places, and like MD5 is bad at this, where you can come up with a password that matches the hash value of the real password, you've basically done just as good as having that password. So you have essentially hacked that system if you can make a hash collision happen and come up with. And hash table reasons we salt. If you come across a system where it's just like, I take a password and I apply MD5 to it. So I take password and turn it into some hash value. I can pre-compute that. I can go through and do an MD5 hash on every word in the dictionary, and then I just look at your hash value table to look for it. Rainbow tables accelerate that a little bit, and that was a huge problem with the early Windows NT domains and passwords, that they wouldn't do anything extra cool to their passwords, and instead they'd be susceptible to hash table attacks or rainbow attacks, which is much the same thing, except you've pre-computed the values for those things so that you don't have to check every single password. So cracking passwords, brute force or dictionary, kind of talked about those. Have a system you can feed passwords to. Like Hydra is a good tool for that. Hybrid attack somewhere between there. Cracking techniques are those things we just talked about. A birthday attack is when you can use sort of statistics to come up with a place where the two passwords intersect. It's called a birthday attack because of the birthday paradox, where it looks like there's a, if you've got more than, I think the number's 23 people in a room, odds are two of them have the same birthday, which seems unlikely, but happens to be the case. And then rainbow tables are pre-calculation attacks like our hash tables. And Patch the Hash is a vulnerability in Windows that Microsoft's operating systems will oftentimes accept the hash value of a password in place of the password, which they've never really gotten rid of. And then you can physically attack biometric type authentication, right? You can try applying actual, photos of people to trick a face sensor, although most of them you would need to have a mask of somebody that's three-dimensional. If there's some authentication engine on the back end, you can try that. Or if they take biometrics / a password, or like every movie I've ever seen, you can chop the hand off of the guy and then bring it to the scanner to get in, which is totally a realistic thing you can do in a pen test. And then these are a bunch of the tools. Again, this would be a good one to go through in your discussions, to pick one of these out and go through and take a look at the docs for it. But Hydra, useful for applying passwords to live systems, whereas John the Ripper, Hashcat are used for, the Rainbow Crack, used for cracking passwords by throwing either dictionary attacks at them or trying to brute force them. Mimikatz is this interesting tool that lets you pull passwords stored in the Windows systems right out of the memory. Super powerful. They've fixed it. There's another version of it. So there's a little arms and armor race going on there. And there's some you will get to play with in the labs for this week. I think that's about it. So now we talked a little bit about how to check those vulnerability scans, the CVEs, how to prioritize them. We talked about how to map those exploits to vulnerability, and then the tools you use to deliver stuff to them. And that's pretty much everything I wanted to talk about inside of about 26 minutes. Questions on any of that? And look,